How can we switch it to the, after this?
Over, yeah, once you start, we'll put it on the screen. Are you
Yes.
ready to go right now? Let's wait
Yeah,
for those.
just let me just hear. Yes. Ladies. All right, can you hear me? My name is Wahab Al-Muhtadi, and I am the past president of Consumer Technology Society. At the same time, I am the Consumer Technology Society Awards Committee Chair and the past chair of Ibuka Award Committee Chair. I would like to introduce our long volunteers of IEEE Consumer Technology Society and IEEE Consumer Electronics Society in the past. And the president of IEEE 2024, as I mentioned, our veteran long volunteer of IEEE Consumer Technology Society, Tom Coughlin, to come here and to stand beside me.
Which I shall.
Yes. So go ahead, Tom, and say something here.
Should I do this? Or
Yes,
is it
yes. Go ahead.
the whole thing? You're already, okay.
And then we will present it.
Okay. Good morning, Las Vegas. So it's a pleasure to be here. Our colleagues, attendees, and esteemed guests, it's great to be back again. It's my honor to join you today to be able to represent the IEEE Board of Directors in this celebration and to present one of our prestigious Technical Field Awards. And in fact, today we are presenting the first Technical Field Award of 2025. The IEEE Masaru Ibuka Consumer Electronics Award was established in 1987 and recognizes outstanding contributions in the field of consumer electronics technology. Sponsored by the IEEE Ibuka Fund, the award is named in honor of Dr. Masaru Ibuka, who was the honorary chairman and co-founder of Sony Corporation and whose innovative achievements in leadership have been an inspiration to several generations of electrical, electronics, and computer engineers. This year, it is truly my pleasure to recognize IEEE Fellow Steve Mann for contributions to the advancement of wearable computing and high dynamic range imaging. Steve is a professor of computer engineering in the Department of Electrical and Computer Engineering at the University of Toronto in Ontario, Canada. It does say that, that's interesting. As an innovator, engineer, scientist, author, and teacher, Professor Mann has significantly contributed to the field of consumer electronics. Widely regarded as the father of wearable computing, and in fact, when he comes on here, he's going to be doing that, Professor Mann founded the MIT Wearable Computing Project, which has had a singular impact on the development of virtual reality, augmented reality, and extended reality products and services. In 1998, he invented, designed, and built the world's first smartwatch, capable of downloading and running a wide variety of applications for health, well-being, and fitness tracking, ushering in a new wave of personal health. More than 30 years ago, Mann also invented high dynamic range imaging, which is now used in nearly every commercially manufactured smartphone, as well as many other cameras and computer vision systems, including systems to help the visually impaired see. He invented HDR imaging in his childhood and brought his invention to MIT and further refined it there. And I believe you're going to show us a demonstration. Once again, on behalf of the IEEE Board of Directors, it is my pleasure to recognize IEEE fellow Professor Steve Mann as the recipient of the 2025 IEEE Masaru Ibuka Consumer Electronics Award.
Okay. Okay, just take one and pass it around. Okay. Okay. So Sustainable Technology Society. I want to talk about sustainability, technology, and society. Sustainability. Okay. So we've got three things: sustainability, technology, and society. It's a Venn diagram. We've got the environment made of atoms, alpha. Alpha is the first letter of atoms as a word. We've got technology, which is bits, beta, and we've got society, which is genes, gamma. We've got a Venn diagram, and at the center of the Venn diagram, we've got this sort of concept of immersivity, which I want to talk about. We've got planet Earth is blue. That's the blue circle. The Earth represents the blue circle. The green represents technology. That's my cathode ray oscillograph from my childhood. And so this is kind of how I grew up looking at technology and understanding technology. The green glow of the cathode ray oscillograph screen. Green is technology. And red is humanity. You know, the red circle represents the human face. And, you know, we're all, if we look at this, we're all humans are red. You know, so this is a simple experiment. You grab a light bulb, no matter what color your skin is, it's always red. You know, the bulb, the glow, we're all hemoglobin. You know, so humans are red. So we got red, green, and blue here representing the atoms, bits, and genes. The physical world of atoms, blue represents Earth. The technological world of bits, green represents technology. And the social world of genes, red represents humanity. If we look at these three circles, the Venn diagram, we have XR, extended reality, in the center here. And at the places where these join, we've got integral ecology is where we look at us as humans and our environment. If we look at technology and humanity, we've got the metaverse, we've got the cyborg, we've got fitness tracker, you know, smartwatch technologies like that, wearables, things like that. And then over here, we've got physical computing, IoT, and so on, where these two intersect. And if you look at the the postcard, actually just open one up over there. If you look at the postcard, actually I'll just fold this up and forget opening it. If you look at, here's how we're dealing with technology. So we've got the three axes: the physical, the virtual, and the social. And we've got three axes here. And at the intersection of them, we got extended reality. And so you've got the physical plane. The plane of the physical and the virtual is physical computing, IoT, digital twin. And then over, this is the color cyan, which is the green and the blue. And the yellow is the red and the green, technology and society. And that gives us metaverse, HCI, AI, social media, data centers. In fact, IEEE slogan, advancing technology for humanity, exists in this yellow plane here. And then down on the ground here, I guess you've got the integral ecology, which is magenta color, which is the red and the blue combined. And so if we look at all three of those, we have XR, extended reality. And so I just want to kind of highlight. And you can follow along with that postcard if you have trouble seeing the slide here. So advancing technology for humanity, that is in that yellow plane to the left. And this is bits and genes. And when we say bits, obviously you can't have bits without atoms. You have to have a physical substrate upon which software runs. So it's a metaphorical or poetic narrative of atoms and bits. And so then we've got genes, you know, again, a poetic narrative here for these two circles that gives us the metaverse, the cyborg, HCI, that kind of thing. Now at MIT, we often talk about Men's Manus and the Center for Bits and Atoms and that sort of thing. And this is the intersection of these two, is physical computing. Now, if we look at that plane, we've got physical reality on the axis going from left to right, and virtual reality on the up-down axis, so atoms and bits, alpha and beta. So from left to right, we've got physical reality, virtual reality, and I've just got these children's blocks here to show that concept. And you can see that it creates these two axes, alpha and beta. And if we have a little bit of one and the other, then we've got augmented reality. And it defines this plane, which gives us all these different realities and a confusing array of realities. And this is when I was at Meta. We founded a company called Meta a while ago, back in 2012. And we made eyeglasses and that sort of thing. And this is what the plane looks like. Now, if you look at more reality and less reality, and more virtuality and less virtuality, we divide that into quadrants. There's a missing quadrant here. You know, these taxonomies help us see missing space. And so we call that diminished reality. Technologies like this baseball cap that I have to cut down or diminish our sense of perception of reality. And that helps us understand the world. Welding glasses, blinders for horses, technologies like that. We can't ignore that. Those are important technologies. So it makes a lot of sense to show those technologies, and it makes a lot of sense to be able to see and understand those technologies, and to literally have an understanding of these four quadrants. Diminished reality, sensory deprivation. The quintessential example is the float tank. In a float tank, there's no stimulus. Your brain, you hallucinate like mad, but there's no zero stimulus, zero signal. There's 0 bits being thrown at you, and there's 0 sound or light or anything. And then over to the right, we've got physical reality, and ice water swim is something we like to do, for example. And then in the upper left, I've got my favorite example. That's me in my float tank with a VR headset on. And that's a VR float tank, and that's a kind of idea of shutting off everything in the world except the virtual world. And so that's pure bits only, no atoms. And then up on the right, we've got I'm going for a swim with my eyeglass there, and I have my head-up display and situational awareness and that sort of thing. And so this is, at the origin, you've got the float tank, and then, of course, you can add VR to that, and we can create this plane. XR, extended reality, extends and interpolates. So X is let X be the space of all realities. I'm kind of getting tired of hearing people say VR/AR/MR, because another MR is another one. It stands for mediated reality, which is yet another reality. So you've got augmented reality, virtual reality, augmented reality, mediated reality, AR, VR, MR. And then it gets so confusing because you've got all these realities, and we simply said let X be the space of all realities to interpolate between them and also extend beyond them. So by extend, I can see into the infrared, I can see the ultraviolet, I can see radio waves, I can see sound waves. I have more than 100% of my sensory capacity. And so the idea now is that I've got extended reality eyeglass here, and I can see more than 100%. I can see situational awareness. I can see inside my body how I'm doing. I'm going for an ice water swim, monitoring my vital signs, and able to actually stay in touch with all of that. So this is kind of how it shapes up there, and you can take a look at that. Now, the metaverse, or HCI, is just two of these circles or spheres, and then we could call this the sustainable metaverse, or we could call it, just whatever we want to call it, but XR is probably the best term for it. Now, we're surrounded by technologies that become part of us. These are immersive technologies, and I've always felt that if it can immerse us, we should be able to immerse it. If it can immerse me, I should be able to immerse it. It's meta-immersive, immersivity of immersivity. And so, otherwise the technology is a prison that boxes us in. And so, we've got the green box as the technology and the red human there, and we've got this this problem. And I grew up in this era where computers were room-sized and that sort of thing, and I had this vision. This is from my childhood. I had this vision that computers would be communication devices as well as computation devices. This is kind of a little sketch I did. And so instead of being hunched over a desktop metaphor, twisting ourselves like a pretzel around the computer, what I thought is I'll tear the computer apart and twist it like a pretzel around me so I can stand tall and I don't have to hunch over and look down at my screen. Otherwise, I'm walking down around like this looking at my device, whether it's a modern device. So this is kind of 50 years since the 1970s. I've been inventing, designing, building, and living in this extended reality. This is a photograph from my childhood. This is a machine that I built to see and photograph radio waves and sound waves. One of my favorite childhood hobbies was photographing radio waves and photographing metavision. I coined the term metavision back in the 1970s, metavalence. And meta is this idea that I had to be able to sense sensors and sense the capacity to sense. A meta conversation is a conversation about conversations. A meta joke is a joke about jokes. Metadata is data about data. And this is meta. This is meta sensing and meta vision. And so sensing sensors and sensing their capacity to sense. So this is a photograph of a surveillance camera's capacity to sense. And so when I was growing up, I did all these things. This is a radar set. I had a police radar plugged into my oscilloscope, and my dad got me an oscilloscope that was broken, and it was being thrown away at the time, and the time base didn't work on it, and the dot would only go up and down. So I was impatient and wanted to see it, so I threw it on rollers on a skateboard and started sliding it back and forth across the desk like mad, really fast, so I could see something on the screen. And I discovered something really strange because I had it connected to a police radar, and it induced a Doppler shift that kind of sheared the space-time continuum in coordinates that made everything the speed of light equal to 0 in that spatial frame of reference. And so what I discovered was what I called metavision or metasensing, and the ability to be able to see. I also called it a scientific outstrument, because the scope is a scientific instrument with everything inside the box, but this is a scientific outstrument with the trace shown on top of reality superimposed perfectly on the real world, updating around 15 million frames per second, roughly. So it's a and down to within a wavelength of light. So it's a reality that superimposed on reality, but connected directly to that reality. This was 1974 when I came up with this. And then Charles Wyckoff and I wrote this 1991 paper about XR. We define XR as a combination of virtual environment with reality, where the virtual environment is responsive to a real or complex valued output from reality by way of real-time computation. And so this is collaborative. This is my office at Meta. Back in, we founded in 2012, and we built these Meta glasses, the Meta 1, the Meta 2, and the Meta Pro. And this is kind of this collaborative shared XR, which is really what XR is. It's a shared environment. You notice that I used to do performance art and that sort of thing, and walk around and be able to see and understand. I'll show you a quick little example here. So what I would do is I would walk around and experience and understand and see the world. And so I have here this machine. So this is, the design is like 50 years old. This is a newer version of it, but I built this when I was 12 years old originally, and it replicated what the oscilloscope did. I got a bunch of Christmas tree lights and put them on a hockey stick and made it into a one-dimensional trace with a digital computer, primitive digital computer, so that as I could walk around, wave the stick around and see things. It's basically an oscilloscope that the dot only goes up and down, so it's a replica of my broken oscilloscope, because then I didn't have to carry around that 40-pound oscilloscope with the 1300-volt cathode ray tube. I got a little thing like this. So now if I move this around, you see if I move my hand fast or if I move my hand slowly, the dot bobs up and down slowly. And if I move my hand around quickly, I don't know if everybody can see that, but afterwards we can take a look at it. I can show you more clearly after. You'll be able to see it close up if you want. I was going to get together this afternoon around the pool and have a bit of a poolside chat. But you can see, if I wave my hand there, you can see that waveform bobbing up and down. And what I used to do, I used to be a cyborg performance artist, and I used to have these things in a dark room. And I made one that was 50 feet long, and I'd whip it around over my head. And so I used to go around photographing surveillance cameras and photographing radar sets and all kinds of invisible stuff. And the thing is, thousands of people can see this. So I'd be in a room with thousands of people able to see this extended reality. So XR is a social phenomenon. So it almost kind of annoyed me to see all these eyeglasses where somebody's buried in their own world and you can't really share it. So there's a really important idea of sharing. Sharing is caring, and being able to see all this in a shared extended reality environment. And so after all these years, these things still work, of course, and there's no HDMI port on this, so it always works. And so the idea, and of course if I go through something, if I go through this stack of postcards, the signal's going to be weaker than if I'm not going through the stack of postcards. And if I go through this rock here, it'll even be weaker a little bit. The rock actually stops quite a bit of it. And the radio waves are weaker going through the rock. Of course, they're weaker when I'm further away and stronger when I'm closer. Out here, they're weak. Over here, they're strong. Now, if I block it with my hand, Do you think my hand will block more or less than that rock, or more or less than the stack of postcards? Yeah, see if I block it with my hand. It's pretty much very close to 0. Now, why is that? Why does my hand block more than even 12 inches of concrete or 12 inches of wood, you know? Any idea? Water, yes. See, flesh is conductive. And so it's a conductor. So when you're holding your phone, this is a little smartphone, as you see the radio waves, when you're holding your phone, you know, don't hold it like this because it blocks all that. You know, hold it like this so the radio waves can get out. So that was an interesting childhood fun, you know, just seeing and understanding. And so I did a lot of fun things. Another piece of my work is I co-founded a company called Interaxon, and we make a product called the Muse brain sensing headband. We had a booth at CES, and and so this is another example. The Muse is a wearable sleep app. So this is you know, really a good example. So I want to think of technology. So immersivity is this idea of it's a social, cyber, physical phenomenon. There's 3 axes: social, cyber, and physical. Phenomenon that connects us to each other and to our surroundings. And you can regard technology as a vessel or a container around us. And so the blue indicates the vessel there, and the green rectangle is the technology, and the red circle is the human. And there's 6 connections between those, and that gives rise to 6 properties. That technology should be unmonopolizing so we can sense our environments. It should be unrestrictive so we can walk, hike, swim, socialize. It should be observable so we can sense and understand the technology, aletheia, truth in the Greek sense, unconcealedness. It should be controllable so it serves us, not enslaves us. It should be attentive to its environment to give us situational awareness, and it should be communicative to others around us, like expressive, like that swim, for example. It's like I'm able to share my experience. You know, my eyeglasses I built years ago, I had an outwards facing screen as well, so people could see my eyes and see you can display my facial expression or eye movements on the outwards facing screen or something else, you know, and create this environment. This is sort of, I've created that the blue drop represents the environment, the lake, the blue earth, the sky, the water, and then my green paddleboard there is the vessel. And then, so I'm on my paddleboard in the environment, and diagrammatically, I've got this nested set. The technology is a vessel that connects us to our environment and to each other and follows these 6 properties. So in conclusion, we would like to advance technology for humanity and Earth, and I've colored those, you know, green and red and blue. So advance the technology, the IEEE slogan, advancing technology for humanity. Let's add to that Earth so that we end up with technology for people and planet, or technology for us and our environment. That is, by us, we mean in the wide sense, not just humans, but other living beings. And more broadly, for the environment, let's care for the Earth and for sustainability. And as I said, technology is the vessel that connects us to each other and to our environment. We're going to have a Immersivity Summit in Toronto on Thursday, March 28th. Save the date, Thursday, March 28th. And today, after the talk, we'll go out to the pool this afternoon when it's nice and warm. Some of us are going to just gather around the pool and sort of sign off on a Immersivity pledge. We want to write something like this. As technology becomes more immersive and pervasive, there's a need to ensure that it serves humanity more broadly, life, Earth, and the environment. Accordingly, we, the undersigned, pledge to advance technology for humanity and sustainability. Whenever we design virtual or augmented environments, we're going to embrace extended reality, extended intelligence, XR, so as to not to unduly limit our well-being. In particular, whenever we design tech that immerses us, we must ensure that the tech continues to connect us to each other and to our surroundings to ensure immersivity. Notably, as we build technologies upon the 3 axes of physicality, cyber, or virtuality, and humanity or society, we shall aim to connect these 3 axes in both directions. giving rise to 6 fundamental properties. That is to say, we wish to make the technology, and I've gone through these already, unmonopolizing, unrestrictive, observable, controllable, attentive, and communicative. So that is our mission, and today, this afternoon afterwards, I think I'm just going to plunk down out by the pool in the sunshine and meet up. Yesterday, Tom Coughlin and I and the founder and CEO of Vuzix Corporation and everything, we kind of met out by the pool, and we had this discussion, a little bit of a recorded interview discussion on the future of technology and humanity and Earth. And so I'd like to kind of meet again this afternoon with a small group of people and just hammer out some of these ideas. If you would like to sort of join this. And we've written something that maybe people will sign off on, or if we could even revise it if necessary. But I kind of want, while we're here in person, to be able to sign, have us sort of sign almost like a pledge or a manifesto that we, the undersigned, pledge to build technologies that connect us to each other and to our environment. Thank you.
Well, thank you, Steve, and thank you to your student there for being able to hold my cell phone steady enough that we could end up watching it. So we have a number of other society awards, which we have an hour or so to give. Charlotte, is the food out there yet? No. Okay. There should be some lunch boxes available to pick up sometime between now and when you drop dead from being hungry. But I think in the next 10 minutes or so. But I believe Wahab has a number of different society awards that he can now give during the next hour.